Have you ever wondered what happens when you take the most expensive, most powerful computer chip on planet Earth and try to play a simple game of Roblox or Fortnite? Today, we are diving into the crazy truth behind Nvidia's $30,000 H100 GPU and why it actually gets destroyed by a $500 gaming console. A lot of tech experts will tell you, oh, it's just not built for gaming, and they leave it at that. But I'm not going to do that. We are going to crack open the silicon, look at the physical hardware, and figure out exactly why this massive server card can barely hit 15 frames per second in most games. And trust me, the reasons are way more shocking than you think. It all comes down to three major bottlenecks, and by the end of this video, you are going to understand graphics cards better than 99% of people out there. Let's start with the very first and most brutal reason why the H100 fails at gaming, and I call this the painting problem. To understand this, you need to know how a video game frame actually makes it to your screen. Every single frame you see is made up of millions of tiny dots called pixels. Your GPU does all this heavy math to calculate the geometry of the world, the lighting, the shadows, and the explosions. But there is one final crucial step. The GPU has to actually write all that color data to specific pixels in a memory buffer that your monitor reads. That writing process is handled by something called ROPS, which stands for Raster Operations Pipeline. Think of these as paintbrushes. The more paintbrushes you have, the faster you can paint the final picture. Now the RTX 4090, which is Nvidia's flagship gaming card, comes absolutely loaded with 176 of these ROPS. That's a massive stack of paintbrushes, which is why it can push out high resolution, high refresh rate gaming without breaking a sweat. It has the raw capacity to blast pixel data onto the screen incredibly fast. But here is where Nvidia made a very intentional and very brutal choice. The H100 is a data center card. It is designed to process numbers for AI, for scientific simulations, and for massive language models. It does not need to output images to a monitor. So when Nvidia was designing this chip, they looked at the limited space on the silicon wafer and made a decision. They physically removed almost all of the ROPS to save space for other things. The H100 has only about 24 ROPS. Let that sink in for a second. Even if the H100 calculates the game physics in an instant, it physically lacks the hardware pipeline to output the final visual image. It is like having the world's smartest mathematician who can solve complex equations in his head, but you hand him a single crayon and ask him to paint the Sistine Chapel. The math is done in a split second, but then the card hits a massive traffic jam because it only has a handful of tiny paintbrushes to draw millions of pixels. This is why, even with all that computing power, you end up with abysmal frame rates. The card is essentially waiting for its crippled painting department to catch up, and it just can't. Now let's move on to the second huge problem, and this one is all about the type of math the card is designed to do. You have probably heard the terms FP32 and FP64 thrown around in tech reviews, but I'm going to break it down in a way that actually makes sense. FP stands for floating point, which is just a fancy way of saying how computers handle decimal numbers. FP32 is called single precision. It holds 32 bits of data and it is coded to about 7 decimal places. This is the standard math for gaming. Video games use three-dimensional coordinates, lighting, calculations, and physics that just need to be fast. They don't need infinite precision. They just need to be quick enough to keep the action smooth. FP64 on the other hand is double precision. It holds 64 bits of data and is accurate to about 16 decimal places. This is for scientists who are modeling weather patterns, simulating nuclear reactions, or calculating the trajectory of spacecraft, where a tiny error at the 10th decimal place can ruin the entire simulation. Here's the problem, and it is a massive one. The cores that handle FP64 math are physically larger and way more expensive to manufacture. The H100 is packed to the brim with these massive FP64 cores because that is exactly what AI researchers and scientists need. But modern games run almost entirely on FP32. They cannot utilize the FP64 hardware at all. So when you load up a game on an H100, a huge portion of that incredibly expensive silicon is sitting completely idle, unable to process the game data, while the much smaller FP32 section gets completely overwhelmed. It is like buying a massive monster truck to deliver pizzas. The monster truck is incredibly powerful off-road, but it is terrible at city driving and takes forever to park. Meanwhile, the tiny section of the engine that actually works for delivery is screaming under the pressure. The H100 is actually slower at game math than a much cheaper gaming card because it is wasting all its brain power on a type of math that games don't even use. It is a classic case of having the wrong tool for the job, and this mismatch alone would ruin the gaming experience. The third and final nail in the coffin is all about memory architecture, and this one is really interesting because it flips everything you think you know about speed on its head. The H100 uses something called HBM, which stands for high bandwidth memory, while gaming cards use GDDR6X. The difference here is between bandwidth and latency, and understanding this is the key to unlocking everything. HBM achieves massive bandwidth by having a very wide bus, meaning it can move thousands of bits of data in a single single clock cycle. However, it runs at a lower frequency. It is designed to stream massive continuous data sets like a large language model that needs to process huge chunks of information all at once. It is like a freight train that can carry an enormous amount of cargo, but it takes a while to get going and it doesn't change direction quickly. Gaming data is completely different. It is random and erratic. As you play, your GPU needs to quickly fetch small chunks of data like textures, shaders, and geometry from random locations in the memory. For this, you need low latency and high clock speeds, which is exactly what GDDR6X provides. Think of GDDR6X as a sports car. It can't carry as much cargo as the freight train, but it can change direction instantly and get you what you need in a fraction of a second. The H100's memory is optimized for throughput, meaning total volume, not response time. In gaming, that slow response time results in stuttering, micro freezes, and low frame rates, even if the total bandwidth is technically higher. It doesn't matter if you have a massive data pipeline if it takes too long to respond to each individual request. The H100 is waiting for its memory to catch up, and while it's waiting, your game is stuttering and lagging behind. So, when you put all three of these massive bottlenecks together, you start to see the full picture. The H100 isn't failing because it's weak, it is failing because of specialization. Nvidia has a limited amount of space on a silicon wafer, and to create the ultimate AI and scientific processor, they had to sacrifice the raw peeps. They had to load up on FP64 cores that games can't use, and they had to choose a memory type that prioritizes bandwidth over responsiveness. It feels almost wrong to call these graphics processing units anymore because they aren't even processing graphics in the first place. They are data processing units wearing a graphics card costume, and here is the biggest twist of all. The H100 is not a bad product. In fact, it is one of the most incredible pieces of engineering ever created, but only for its specific job. If you are training an AI model or simulating a galaxy, this card is an absolute beast. But if you try to game on it, you are going to be incredibly disappointed. It is like asking a fish to climb a tree. The fish is an amazing swimmer, but you wouldn't expect it to win a race up an oak. The same logic applies here. You could spend $30,000 on this card, and a friend with a standard gaming PC will have a smoother, faster, and more enjoyable experience. So before you ever get the crazy idea to drop a fortune on a server GPU thinking you are going to max out Cyberpunk or play Minecraft with 1,000 mods, just remember this breakdown. It is not about raw power. It is about having the right architecture for the right task. The H100 is a scientific instrument, not a toy. And while it might look impressive sitting on a shelf, when it comes to actual gaming performance, it is one of the worst investments you could possibly make. If you want to see more deep dive explanations on how your favorite tech actually works under the hood, make sure to hit that subscribe button and ring the notification bell. I have so many more mysteries to uncover, from CPU bottlenecks to the secret reasons why your internet lags. But for now, just remember that sometimes the most expensive thing in the room is not the best one for the job. I will see you in the next video.